Okay. Okay. You're good to go, Mikey.
All right. So, kind of what I wanted to ask is what is people's familiarity with Linux? So I don't, because I've been using, I'm like, compared to Windows, I'm like a Linux. I know a whole lot of stuff with Linux, so I don't want to skip over things that are details I should include in my explanation. So it's kind of just a question to everybody that's kind of watching, if you guys want to talk, or if you don't, it's okay.
Yeah, I'm really good with Linux, but then I think some of the others might not have as much experience with Linux. So, kind of play it by ear in terms of how much details you want to give. And then the thing is, we can always interject if we have questions, right? So we've been really
Yeah,
good
yeah, yeah.
about that.
That's kind of. I'm gonna kind of keep this open, so
Okay.
people can be feel free to interject if they want. Okay. So yeah, that's for anybody if you guys want to stop me. Okay. So kind of what I wanted to walk through today is some stuff I'm doing for my master's thesis here at Purdue University. Uh, I'm doing a little bit different applications from what I'll present today, but the tool I'm going to be using is what I'm using in my research. So I'm going to close these. These are from Candy's thing. What I'm going to walk through today is kind of a really, really, really simple Linux rootkit, how it works. And then I'm going to go through a pretty novel defense that was written by some guy from Poland. Uh, and it helps defend the Linux kernel from runtime exploitation attempts. And then I'll show it actually stopping this rootkit. What I want to start with here is going over what this GitHub page is. And so this is kind of a GitHub page that you can use. I guess I'll include these at the end of the presentation, right, Candy? You want us to send like the URLs and stuff to you so you
Yeah,
can put
just
them in the
shoot me
video.
an email.
Yep.
Yeah.
Yep. I'll get it to you after the presentation. So what this directory is actually an explanation for how to write Linux rootkits. So if you look here, there's the first thing that kind of teaches you the Linux kernel fundamentals. The second thing is actually some basic rootkits, and then third and fourth and fifth. I actually haven't really gone through these because I kind of just got what I needed from the second direct chapter, I guess. But you could go through all these if you wanted to learn more. But one we're going to walk through today, I've got it pulled up here in my VM. Let me learn my password. Haha. Um,
Is that Susie? Suse?
no, this is Mate.
Ah, interesting.
I like, yeah, so can you see it here if I do?
So we see the
No.
top left corner. I'm seeing the top left corner of your image, but not the rest of the screen share. So maybe it's a
Oh, crap.
refresh thing there. I think you have to refresh, yeah, to sort of get it
Is
to
it good
update.
now?
So the top are okay. I see the top half of your screen, but not the bottom half.
See, this is a problem that I was having earlier too. Dang it. I'm sorry.
No
Uh,
worries.
should, do you want me, actually, I'm just going to stop sharing and then I'll share again. It should be good.
Yeah, give that a
Uh,
shot.
all right. I
Okay.
might have to, every time I switch, I might have to do that. I'm sorry.
Oh, no
Okay.
worries. Okay.
Uh,
Looks
so
good. Yep.
kind of, where is my rootkit? Cool. Okay. So the program I'm using here to kind of display all this stuff is Tmux. If you're curious about what that is, I can provide a link to it. But essentially, it's a multiplexer that lets you run a bunch of different terminals and control them all from your keyboard, which is really nice. So here, we're going to kind of look at the rootkit, but what I wanted to look at before that was so I should have had this pulled up. I'm sorry. Oh, okay. I guess I don't. Oh, yeah. Here we can look at the makefile. So I wanted to kind of walk through how this rootkit works. So if we look here, this rootkit actually operates as a kernel module. So what is a kernel module?
So the top right
The way to
isn't
run it.
refresh. So try. I think if you just move your windows around to have it refresh, you're there, and then there you go. That's good. Now you're good.
It's good.
Yeah.
Cool. Okay. Can you like if I change stuff? Can you see it?
Yeah.
Cool. Okay. So yeah, because I'm running Zoom through the browser, so I think that I don't really like Zoom software running on my computer. So that might be why there's some issues. Okay. Anyway, so I wanted to talk about what a kernel module is. So if we go and look at the Linux kernel, and we do ls mod, we can actually go and see here that in the background, the Linux operating system is actually running a bunch of different what you can call modules that implement a bunch of different functionality of the underlying operating system. So if we look here, we can see different FS's different file systems that you can hook into your Linux computer. What's another like famous one? IP tables. This is the Linux firewall. We look here. And there's like a bunch of other stuff. I don't really. There's like a bunch of. I've got KVM. So KVM is the Linux kernel virtual machine. Like I think like the most popular virtual machine program in Linux. But anyway, there's a bunch of different modules. And so what this rootkit does is it installs a super secret with quotes super secret program that kind of runs in the background of the OS, and so when you install this as a module, it's actually installing another, like it's adding functionality to the kernel itself. And so a lot of times rootkits, if they want to install themselves as kind of like a backdoor on a Linux operating system, they will position themselves in such a way that they're written as a kernel module. And then when they get root access to the host operating system, so like right here you can see I can do ID and I can see I'm running as master. But if I do su and I can run as root.
A screen refresh. We need a screen refresh. It's not showing the commands.
Can you see now?
No. There it is. The ID command. So I see the ID.
Yeah.
SU. Yeah. You're good.
Dang it. Okay. Sorry. There's all these. I'll have to get this figured out for next time. But so we do like sudo su, and we run as root. I didn't really like prepare this super well, so this might be a little rambly, but hopefully it's like somewhat organized. I can actually type my password right. All right, there we go. We can run ID, and then we can see here we're running as root. So where was I going with this? Yes. Okay. So how does this specific module work? How does this rootkit work? So we can see here you've got the init module function and the cleanup module function. So every basic kernel module that you're going to see, they can look a lot more fancy like this, like a bunch of underscores and stuff. That's just fancy syntax for the Linux kernel. But every kernel module is going to have something that it runs when you load it. So I'll show how that works in a second. And then when you remove it, it runs a cleanup module step. And so if we look here, what this rootkit, we can call it a kernel module rootkit, it's kind of the same thing. What we want to look at, what is happening when we load this module. So it's going to send us a alert. So I think what this function does is defined somewhere else, but essentially this is going to write this string into dmessage. And so what is dmessage? Dmessage is Linux. You can think of it like, actually, I really don't know the Windows equivalent because I'm not a Windows expert, but essentially this is like Windows main logging utility for everything that happens in the kernel. And so you can see here, if I do dmessage, it says, oh, here's Docker running. I'm running a Docker container on this machine. Then I connected like a bridge or something. But if we go to the, if we do like, I think there's a way we can list like the whole dmessage maybe. Let me see. Yeah. So you can see like all of the dmessage history here. And basically it's what thing said something, what was the string it said, and then what was the time it went. Anyway, so that's what that's doing.
Could you move those to the top? Because what I'm seeing is that the top half of your window, it's really good at refreshing, but everything you do in the bottom half, it's not refreshing.
Here, let's just like make this smaller. Let's see if I can do that. Nuts. Can I like make this smaller? Okay, cool. Now can I play with Windows? Can I play with you? Can I make you smaller? Okay, you're not letting me like drag. There we go. Okay. Let's see. All right, how does this work?
It's almost, but there's some artifact with the top right. There's like a top right thing that didn't refresh yet that's blocking your, there, now it refresh. Okay, now it looks good. Now you're good.
Cool. Okay, so let's see. All right, so now if I like move up and down, can you see it when I move up and down?
Yeah, your left window has always been good. It's just your right bottom window that has been troublesome. But
Can you
now
see
it's
that?
good. Just
All right,
just the
cool.
first part of the command.
What do you want to see? D message?
So with dmessage, it's just showing the left timestamp. That's it. So I'm guessing the left side of your screen is like the ideal. There you go. If you move it to the left side of your screen. Yeah, I think
We'll
it's
just
the
do
top
this
left
all
corner is what's refreshing, unfortunately.
right here.
Yeah, the top left. Yeah, if you just do everything
All
in
right, hey,
one
it's okay.
window
It's
in the
okay.
top
We can
left,
just
unfortunately.
it's okay. Don't worry about it. We
Okay,
can.
cool.
What's really cool, actually, here I'll show you what I did with Tmux there. So like, I can break. I have it mapped to Control A. I can do a Control A exclamation mark, and it breaks it out into another pane. So
Nice.
like, yeah. So anyway, this can you see the message now?
To the
I'll
top
just do it.
left. Yes,
Okay. Is that better?
that's better. Yeah.
All right, cool. We'll just keep it there then. So, this I think I should be able to make this work. Okay, so let's see. So the you can see here the time, whatever service or module or executable output, and then you can see the string that goes along with it. I think this might actually correspond to the specific module that ran this. I'm not exactly sure what thing puts the string here, but anyway, we can see here, where are we at? All right. Oh, nope, we have that open in another screen. Let's see if that is here. Okay, cool. So going back to the rootkit, we can see here, how much time do I have, by the way? Like how much time do you want me to take?
If you can wrap it up within around 10 minutes or so, then we can
Okay, cool.
have yeah, the
I'll
next
move.
person.
I just need to know how fast I need to move, so I'll move a little faster then.
Yeah.
Essentially, what this proc create is doing is creating a new process in Linux, and we're passing in. Honestly, I don't really know what these flags are doing, but I'm guessing it makes it readable and writable in some fashion. I don't know exactly what those flags mean, but if we go here, we see it's passing a variable by reference with the ampersand, so we know that's referring to some kind of memory address. So we can look up here and see what is actually defined with proc fops. So we can see here it's a file operation structure that redefines write operations with this write handler function. So what's happening here is in this process, anytime it's going to write, we're actually going to run, instead of the normal write syscall, so like normally in Linux, if we wanted to call write, we could do like man write, and you'd see, oops, man to write. You'd see here it's calling write. However, what we're doing here is overriding that. What this module is doing, it's overriding that write with our malicious write handler, and so we're going to see what this does. So here it allocates some memory to store in the input. That's these first two steps here. Then it's going down here and it's actually going to check and see, based on that input, does it equal this authorization string? I'll explain what that is in a second. If is the length of the input equal to the length of our authorization string? If the length is right, then we'll do a string comparison. We'll compare the input to our authorization string, and if it is our authorization string, what we'll do is we'll modify the credentials of our task that we spawned up here. Remember when we first initialized the module, we spawned a task called entry, and so we're going to modify. Actually, no, it might be the task that gets passed. I'm sorry, it's been a hot second since I looked at this. No, it's going to modify the task credentials of the current. Yes, this is right. That's right, because that's how this works. It's going to modify the task credentials of the current process that's calling write handler. Actually, yeah, because this is the process that's created here. Because remember, the current process that's going to call this function is going to be using the special structure, file operation structure that we set up above. And then it's going to override the task credential structures and make it a root process instead of just some regular process. So how can we use this write handler to get root permissions? And in the cleanup module, it's just removing the process and running it. So how can we actually use this module to get root permissions? So hopefully my screen doesn't screw up again. Can you see
It's
my?
good. The screen is good.
All right. So if I do ls.
Yeah, it's mostly good. Yeah.
Okay. Can I make it like smaller maybe? Here, let me see. Let me see if I can just like drop it. Can you like see it here?
Yeah, we can see it.
All right, cool. But you can't like none of the other stuff refreshed yet?
The other stuff didn't really refresh, no. But
okay, that's okay.
The terminal.
But you can see like the rootkit stuff?
Yeah, the rootkit we can see, yeah. All
right, perfect. That's what I need. Okay. So we go here. Oh, I see. I see what the problem is. Okay, I can see what it's sharing. Okay, so we go here. Okay, well, I make this a little bigger. I think I can see my screen sharing. Actually, let me try and see if I can, because this is so small, you're not going to be able to see anything. Let me see if I can just go there, stop sharing my screen, and redo it. See, stop share. Redo share. Okay, screen 2. Okay, is it all good?
Yeah, it's all good.
All right, that's what I'm gonna do then. I'm just gonna stop sharing and resharing, and that's what we'll do. Okay, so we can see here we're gonna go into rootkit, and we can see here I've already compiled the rootkit, and we can see the KO is a kernel object, so that is our kernel module that we're gonna insert. And so in order to insert a kernel module, we're gonna do insert mod rootkit ko.ko, and then we got to enter the password, which I think is like password 123 or something. I think. All right. Okay. So normally, what would happen is you would have some kind of exploit that gives you root permissions, and you would install this rootkit with the exploit, and so then this would run in the background. But for simplification purposes, I wanted to show a really simple rootkit, so I'm just using sudo permissions to install this rootkit as a kernel module. But if we were an actual rootkit, we would use some kind of kernel exploit to actually go and install this thing maliciously. So that's kind of why I'm using, normally with Linux, if you want to do anything as a super user, you use sudo to run things as root. And so in this case, whenever you want to install a kernel module, you have to use sudo to use insert mod, run it as root, and insert the kernel module. And so I'm kind of simulating, I'm skipping a few steps in the exploit process just to install the simple kernel module. So if we go here, we want to see, remember we saw that it should install some kind of process. So if we do PS, oh crap, what happened? Normally you can do PS and it'll show like processes. And this is a bug I actually ran into when I was testing this stuff. But if we go into /proc, or we want to do ls/proc, proc less. So less is a terminal thing that will give you the ability to scroll through the standard output of whatever process you just ran. So what I'm doing here, I'll explain that command here. I'm using ls/proc, I'm piping it into less, and then less is going to let me scroll through the output of ls/proc. And so in Linux, the proc mount is actually showing all of the process IDs that are running currently on this operating system. So we see here, there's this really big PID here. Why do we have a huge PID here? Well, if you actually go back in and you check the rootkit code, when it runs that process, the PID it uses for that process is the SHA-512 of the string rootme, which is pretty interesting. So anyway, we can see that our evil process is running. So how do we actually use it to get root? You show me vim rootme.sh. So no. There we go. It's O's instead of O's, or zeros instead of O's. My bad. Okay, so because we use leet speak instead of just regular typing. So if we want to look at, this is the right one. Okay, so what we're going to use here is we're actually going to use our backdoor that's been installed with our rootkit, and we're going to actually run a bash script to use our backdoor and get a root shell. So if you want to check me, we can see here I'm going to run ID, show that I'm running as the master user, and that this root me program doesn't run with any special permissions. So you can see here it's owned by master, and it's got normal rewrite or execute permissions. So this is just like a normal bash script. So if we go in and analyze the bash script again, are you able to see this, by the way? It's not.
We see some of it, like the initial scripts, but then it didn't refresh properly, so the recent commands didn't show up.
Crap.
But it's fine. Like you're talking to it, so like I understand what's going on though.
All right, cool. Okay, so here I want to. Can you see the script? Is there a way I can like? Okay, that didn't work. I wanted to see my screen. There's like a preview button, but it doesn't like show me it doesn't show me a good preview. Okay, anyway. So if you can you at least see the script?
Yeah, we see the script.
All right, cool. So I'll try and keep everything. I'll just keep clearing my screen and try and keep in the upper left so you can actually see it. So let's see here. So we have ID. Okay, so what's happening here with the script, honestly, we don't even really need this part. That was just part of like the demo in the original file. What we're doing is we're echoing the SHA-512 of rootme. Remember, that is our authentication string, and we're passing that into our process, right? So remember when we write to this process, it has a write handler that will execute and check to see what gets written to this process and checks to see if it's authentication string. And so we can see here that we're passing the authentication string writing into this process, so it'll actually execute our rootkit, okay? And then once we're authenticated, we're going to then execute sh, which should pop us a root shell. So if we run it here, we'll clear it so you guys can see. Can you see this?
Partially. But just run it and see if it kind of shows maybe, because sometimes it updates, sometimes it doesn't. So.
Dang it, dude. Frustrating. Okay. Can you see it?
Yeah.
All right, cool. So we're going to run our bash script, and you can see here we got logged in, and it made us a root shell. Oh, yeah, the way we can check that is we can do ID, and that'll show us that we're root, and we can even do who am I, which is like the classic. Whenever you see exploits that run in the wild, they'll always show ID and who am I just to show that they got root. And so we can see here we have a root shell. So I was supposed to have more time, but I'm going to quickly walk through how LKRG works, and we'll show it stopping this. Hopefully I'm not going too far over time.
Just keep on going, man. Let's.
All right.
You're doing great,
cool.
By the way. It's awesome.
Cool. I hope this is all making sense. So.
Yeah. It's awesome.
Can you guys see my screen?
Yes.
Yep.
All right, cool. So here I just pulled some slides from the original author of LKRG, and it kind of explains how it works. So he says it supports ARM and ARM64. It really doesn't. It's really just an x86 64 defense mechanism because some of the stuff it's protecting against is so tied into the kernel that it's based on certain protections that are only available to x86 64 systems. So it really just runs on x86 64 systems. So if we look here, we can see LKRG is an integrity check and anti-exploitation tool. So how does it ensure integrity checking? So it looks at critical CPU metadata, critical kernel variables, and the readable sections of the kernel. Okay, so what is critical CPU data? The CPU metadata is a lot of stuff, but the really important things that it's checking are specific flags in the register of the CPU that enable. Actually, I should probably go pull up a web page for this map. that enable supervisor mode access prevention and supervisor mode execution prevention. So if we say here, all access prevention is doing is preventing code from running in user space that executes with the permissions of the kernel. And then if we look at supervisor mode, SMEP, whatever the fuck you want, whatever. Sorry, I don't know if we're supposed to cuss.
No worries.
But if you look at SMEP, what we're doing, crap, where'd it go? Where'd it go? Where'd my thing go? Yeah, okay. So if we look here, SMEP is supervisor mode execution prevention, and both of these are set in the CR4 register. And that is an example of some CPU metadata is protecting. So why are those important? When an attacker is attempting to run an exploit, they're most of the time going to have their code actually existing in some kind of program that they've just installed on the computer, but that's in like a regular user directory. And so if they want to run that code that's in that regular user directory, the SMAP prevents that binary from actually running with supervisor or root privileges. And then SMEP, I think actually I might have mixed that up, but I know SMEP prevents that binary from running with root permissions. So the other thing, and then the critical kernel variables is just like other kernel stuff. I don't really have time to explain it. But then the thing that's going to be important for what we're looking at today, I probably should have just explained this, but if you look at the task integrity portion, we're looking at critical attributes and control flow. We're not really worried about control flow. That's ensuring that when you return from a function, it returns to the location area that you think it should. We're not worried about that. We're worried more about these critical attributes. So what are the critical attributes of a task or sorry, a process in Linux? So I'll stop my screen share again because I'm gonna switch screens, but hopefully I can share my screen again and it like actually lets me share. So let's try that again. Share screen 2. Okay. So I want to look at I want to make this big again. Actually, this isn't what I want. Shoot, it went away. Okay, well, anyway, I wanted to look at the README. Yes, because I think this explains it better. So I was talking about processes, and I was talking about the important parts of the processes that it's running. So if we look here, this is the GitHub page for LKRG, and we can go down here where it talks about module parameters, and we can see here enforcing, but we want to look at is kernel integrity validate, process integrity validation. Okay, so actually this isn't a good explanation. I should have had something ready for this. I thought what I would be doing would be a better explanation, but it's not. Okay, so anyway, since we'll do this then. So instead, what we'll do, I was going to kind of walk you through the LKRG code, but I don't really think we have time for that. So instead, what I'll do is kind of show you what. Actually, yeah, I should be able to do this actually with this. Nope. Where it's protecting the, is this what I want? No, it's not what I want. No, where did my thing go? There we go. Nope, that's my rootkit. Where did my, shoot. There we go. Okay, but then, oh yeah, because then you go to source, and then we're gonna look at, that's what I wanted to do. Okay, sorry about that. So we can see here, oh, this still isn't a really good visualization for what like task structures is protecting. Actually, maybe, I can use the slides. Let's see. Sorry, I should have had this ready, but I thought I did, but I don't. I wanted to.
So no worries. But then it's like for this demo though, I think if you can just show that you run the protection and then that blocks the rootkit, that's sort of a good stopping point. And then I think on the next one, then you could go into the details, right, about all the different data structures and how it's actually working.
I should have just done that. Sorry, Candy.
No worries.
All right. So here, if we look at all right. So we can go into LKRG. I've already got it compiled. So we can see here, you would run, in order to make this, you can just run make. And you can see here, it's got our kernel object, plkrg.ko. That's our kernel object. And so what's really interesting about this project is that it attempts to secure the Linux kernel while running as a kernel module itself. So what's really hard about that? Because it's trying to secure something. Normally, when you try to secure something, you're trying to either run a higher privilege process that's securing the lower privilege process. So in running a kernel module to secure the entire kernel is a really daunting project. So it's almost impossible, because at the end of the day, once you get root on a system, you're able to do whatever you want. And so it's really interesting how this works. So if we load, we can do sudo insert mod and load the module. And we can see it got loaded. Then we can actually even check dmessage, kind of what I was talking about earlier. And we can see here that, oh, shoot, I forgot. I need to remove the old. So if we do sudo lsmod, and we grep for rootkit, we can see that yeah, okay, there we go. So we can see our rootkit is actually still running. So we'll go ahead and rmmod the rootkit, and we'll load it after we've loaded LKRG. So we can do here, we can do lsmod, and we can see here LKRG is currently running, and in the dmessage logs, we can see here that LKRG got initialized successfully. So what we want to do is go in our rootkit.
Could you clear the screen? So
oh yeah, sorry, I forgot.
Thing goes on the top. Okay, there, you're good. You're good.
Cool. So we can go into rootkit. There we go. Okay, can you see it again?
Yeah, that's good. Right now.
All right, cool. So we can go to rootkit and we can do sudo insert mod rootkit. Yeah, there we go. rootco.ko. Cool. And we can see rootkit got inserted, and we can do ls/proc into less, and we can make sure that it's actually running. And we can see here, we got the long SHA-512 of the process actually running. And let's see here. So now we're going to go. And so the reason when we loaded the rootkit, it didn't actually detect it, because loading a module as the super user is actually normal permissions. And so the way LKRG is designed, it won't actually detect that our backdoor is loaded. But once we try to actually exploit our backdoor, it'll actually detect us and show that, hey, we can see you're trying to manipulate the credentials of this process and change. Because what happens where the reason our exploit works is because it takes our bash script, it manipulates the credentials of that bash script so that instead of running as my normal user, it then runs it as the super user. And LKRG actually detects this manipulation of the task structures and it stops it from running. So we've used LKRG to stop this rootkit from running. Are there questions? I hope that made sense. I'm sorry, I kind of had a little blurb there in the middle where I kind of spaced out, but that was kind of it. I hope this was useful.
Yeah. So my question is, according to your understanding of the protection mechanism, I'm curious. about where it checks. So I guess when it tries to access the credentials, is that where the protection comes in?
No. So the way the checking occurs, we can actually, that's the thing that I was going to show you. There we go. If we go into, I'm going to share my screen again. We can go to the README. Can you see? Okay, no, it didn't share. It didn't refresh again. Sure. So if we go into the README, okay, you can see the top part of this. So we'll see if we can show you this part. Yeah. So if we see here where it tries to validate, we can see here that. Yeah, so we can see there's different options. So we can validate a task credentials just before it gets used, basically right before the task credentials get used. And so kind of the way that works is right when you load LKRG, I should have explained this, sorry. Right when you load LKRG, it actually loops through all of the tasks. Sorry, the processes, task and process in Linux are the same. It loops through all the processes that are running in Linux and it records their credentials. So essentially, like, what is the user? The example here you could think of is like, what is the user that's running these processes? And it stores that in a database inside the kernel. I should have explained this. I'm sorry. It stores that in a database in the kernel. And then whenever a process is going to try and use its credentials, essentially it's going to try to do something that would require root permissions. For example, run a shell with root permissions, kind of how our exploit works. LKRG will check and see it did this process when this process first spawned, did it actually have root permissions? If it didn't, it's probably trying to use some form of privilege escalation. And it stops that. Does that make sense? Does that answer your question?
Yeah. And so with this rootkit, does that break how sudo works, or is sudo like whitelisted as okay?
Oh, no. So the rootkit isn't using sudo because it's actually running.
No. My question is that mechanism, right? Like programs, so bad malware programs, right? They're regular users and they try to privilege escalate. But with sudo, right, that's sort of a regular user, but then somehow that spawns something that uses root privileges with sudo.
I don't know. It doesn't break sudo, and I can't remember exactly why it doesn't, but I think it's because sudo is a process owned by root, and so I think gotcha. If I remember correctly, sudo itself runs with root permissions, and so sudo, when you run sudo, it actually takes the process that you want to run. Bye, Jay. It takes the process that you want to run and it runs it like re-executes it as a child of sudo, so that the permission chain from sudo is still maintained. Okay. So this won't actually break sudo.
Makes sense. Okay, that makes sense. Cool. Any other questions, comments from anyone? Okay. Mikey, really good job. I really like your explanation of SMEP and SNAP. And I think that's really interesting. And, you didn't have much time, so there were a lot of other details. So, I'm definitely, if you're interested, potentially hearing more of the details about how it actually works. But another question I had for you, Mikey, is that security stuff within the Linux kernel is a very hotly debated topic. And for every sort of new features and previous functionalities and features, there has been sort of flame wars about, why it's a bad idea and why it's a good idea. I don't know if you sort of are on top of that in terms for this mechanism. Is it well received, or are there a lot of complaints about it as well?
No. I had to do a lot of reading because I had to really sorry, my explanation kind of was ill prepared. I should do better next time.
No worries. This is why we do it. That way, we have this opportunity, and yeah, it's all good, man.
Yeah, it's good. It's good practice because this is kind of I'm getting better at having more clear explanations for things. So, but anyway, your question was what was your question again? Sorry.
Yeah, the question about how is this security feature seen by the Linux
Oh
kernel
yeah.
community?
So if there is a site called lwn.net, which is for Linux news,
Yeah.
and that's actually where a lot of kernel news gets published. And someone wrote a post on LWN about this tool. And so I think currently this tool is kind of seen more as not industry ready. I think even the authors themselves, because they don't develop this full time and it's just in their free time, it's still kind of a beta project that's not really ready for um, uh, industry use. But I think what's really interesting about this is it's another tool you can use in a defense in depth approach. And I think that's what's really interesting about this tool. Now, a lot of people might say it's not super useful. Others might say it's just really interesting. So I think it runs from people that are running huge Linux servers aren't going to run this thing because it's very experimental and it could script a lot of stuff. Whereas your home Linux user might use this because it's a little fun little security extra little security blip that you can add to your Linux machine running at home. The thing that's really cool about this tool is it's actually programmed in such a way it can basically compile on any Linux kernel version that you've got. So that it's very pick up and go and modular in that way. So, but I think to answer your question, it's more of a play project right now rather than being really useful for anything.
Gotcha.
That's kind of the authors would love to, I think, have it see more adoption, but right now I think it's more of a play project for a lot of stuff. There's actually, I think, in the mailing list, there was someone talking about moving LKRG to Android. So we'll have to see. We'll have to see what happens with that. But
Cool.
yeah, that's kind of where it's at right now.
All right. Nice. Okay. So let's finish that demo for now.